I've had this forever. I just have not, I don't know why I haven't used this, because it's great in case a student misses a day, right? I've already recorded myself teaching this. Duh. All right, ready? Here we go. Everyone has a calculator? Does everyone have a calculator? You're going to need one for today's lesson. Grab one if you don't have one, quickly. Okay, chapter 5 is all about triangles again. But we're going to specifically deal with right triangles. All right, so in this triangle, or in this chapter, we're going to deal with a lot of triangles that have a 90-degree angle. And I would ask that you really pay attention to this first part, because you're going to need this skill to be able to do the rest of the lessons in this chapter. All right, so the first thing we're going to remember how to do before we learn about the geometric mean, we're going to remember how to simplify a radical. Does anybody know how to simplify a radical? What we're doing when we're simplifying a radical, Dakota?
Find a common factor.
Okay, we're finding a common factor. We're trying to figure out what numbers go in to 20. So if you put square root of 20 in your calculator, it's going to give you a decimal. So we are getting away from that. You never, in this class, will give me a decimal answer. You're going to give me a square root that has been simplified, okay? So if we think about what two numbers make 20, what would you guys say? 10 and 5. Okay, what else make 10? Or make 20? 4 and 5. So I'm going to use 4 and 5. Okay, so this is called a factoring tree. I want you to write this down with me. What makes 4? Okay. Now, we can't break 5 down anymore, and we can't break 2 down anymore. Okay? We are looking for pairs of things. Does anybody know why we're looking for pairs of things? Anybody know? There is a hidden... Oh man, that just went away. There is a hidden 2 right here. You don't need to write it. But that's where we get the square root. There's a hidden 2 right there. In Algebra 2, we will talk about when there are different numbers there. Okay, but this 2 is called the root. That's why we say it's the square root. Now it all makes sense, right? 20 years of math all coming together. Okay, so we said 4 and 5 and 2 and 2. So we're looking for a group of 2 things. So if I have a pair of 2's, okay, for every pair that you have, you only write it one time because we're looking for groups of them. So I like to think of the square root sign as a house, and to go outside the house, you have to have a buddy. All right, so to go outside the house, you have to do the ones that are circled. So on the outside of my square root, I'm going to put a 2. On the inside of my square root is going to be this 5, because the 5 didn't get circled. The 5 didn't have a pair, so this is 2 radical 5. Now, if you have one of the little scientific calculators, it's going to do this for you, but I don't want you to use that. I want you to actually use your brain, okay? So 2 radical 5 would be simplified. Okay, what about this one? The square root of 9 over 16 looks a little bit scary. We're going to first rewrite this as the square root of 9 over the square root of 16. So we're going to break it apart. The square root of 9 over the square root of 16. And what is the square root of 9? 3. And what is the square root of 16? So this just reduces to 3 over 4. Notice the square root signs are gone because I found the square root. Okay? What about the next one? The square root of 56. Yikes. I don't know what makes 56, do you? Okay, so let's just try with our calculator. Let's divide by 3. 156 divided by 3. Not square root, but divided by 3. 52? Okay, so we're going to break this apart to 3 and 52. What makes 52? 26 and 2, is that right? What makes 26? 13 and 2. So again, we're looking for a pair of things. Do I have a pair of anything? I have a pair of 2's, but they didn't come from the same root, did they? Does that matter? It doesn't matter. You're right. It doesn't matter. The way I like to think about it is all of these people are inside the house. All these numbers are inside the house. They might be in different rooms, but they're inside the house. So you can still put them together. So we're going to put these 2's together. Remember, if you have a buddy, you get to go outside. So we put a 2 on the outside. But what goes inside?
You gotta multiply them 2.
Good. We have this 3 and this 13 that nothing happened with them. So we have to multiply 3 times 13. 39. So I have 2 square root of 39. This would be all the way simplified. Okay, now we have 8 times the square root of radical 49. Times the square root of 49, sorry. So we are going to forget about this 8 for a minute. We're going to set it off to the side. So just put a bracket around it. What is the square root of 49? 7. So I know, and if you didn't know that, you could break it down to 7 and 7, and look, you have a group of 7s, right? If you didn't remember that. So 7 comes on the outside, but what happens with that 8? How did you know to multiply? It was a great guess. Because look, anytime that you have two things smashed together, they mean multiplication, right? And so right here I have a multiplication sign between 8 times square root of 49. So this 8 comes down, and 8 times 7 is 56. Questions on that one? All right, moving right along. What makes 32? 8 and 4. Now, we have that 4 on the outside, so again, let's put it off to the side. Okay, we'll remember it later. So you said 8 and 4? Four is 2 and 2. Another 4 and 2. 2 and 2. Okay, so we're looking for pairs of things. All right, so do we have a pair of anything? I have a pair of 2's here. I have another pair of 2's here. So for every pair, I write it one time on the outside, right? So I write 2 2's on the outside. And then I still have this guy, right? He didn't get to move anywhere. So he's going to go on the inside. So 2 times 2 is 4, so I have 4 radical 2. Is this finished?
No.
Why is it not finished? Right, I got this 4 over here, right? I forgot to bring that out, so I'm going to... Okay, this is kind of a mess. Times 4 on the outside. So 4 times 4 is 16. So my final answer here is 16 radical 2, or square root of 2. Because I had 2 groups of 2 in the red. See, in the red I have 2 groups of 2. So I'm going to multiply 2 times 2 to get 4. You with me? Over here, I did 2 times 2 to make 4. Okay. Okay. I'll catch up with you later, okay? All right. Any other questions on this real quick? All right. Let's move on down. I got to move my paper down. Too far. All right. Here we go. So now you're going to get a little bit more complicated, but we are still going to be able to do this. So if we look at this first one, it says the square root of 500 over 20. I'm going to deal with 20 later. So let's just break down the square root of 500 over to the side. 50 and 10, that will work. Okay, you're doing this on your own paper. You know it goes into 50, you know it goes into 10. Keep going, guys. Don't just wait for me to do it. Think about what makes 50. What'd you guys say? Because I can get rid of it now. All of it. All right, so I have a group of 5s. Does it matter that they're not beside each other? No. What else do we have a group of? 2s. Good. So I'm just going to circle them and then connect them with a little branch. So I have a 2 that comes out. I have a 5 that comes out. What stays inside? The other 5, right? Oops. So this becomes 10 radical 5. You guys okay with that? Okay, so the numerator becomes 10 radical 5. Over what? 20. Okay, now, interestingly, doesn't it look like all of those numbers will divide by 5 evenly? Right? But the problem is I'm not allowed to touch what's underneath the radical. Okay, so even though the radical will divide by 5, I'm not allowed to touch that because it's been all the way reduced. Instead, I can reduce these two, 10 and 20. So what is 10 and 20 reduced to? 1/2, right? Or 1 over 2. So I can write this as 1 square root of 5 over 2, which is the same thing as just the square root of 5 over 2. That's it. You don't have to put the 1 there if you don't want to. You can just put the square root of 5 over 2. Okay? Let's talk about G. We have in the denominator a radical. The rule is you can never have a radical in the denominator. Does anybody remember how we get rid of a radical in the denominator? Multiply by. Good. Excellent. Some of you are like half asleep. You need to wake yourself up. Sit up. Slap yourself. Something. Have your neighbor slap you and I won't look. Just do something. Okay. So whatever is in the denominator, that's what I'm going to multiply each side by. Top and bottom. So I'm going to multiply the top by the square root of 7 and the bottom by the square root of 7. What is anything divided by itself? Like what's 100 over 100? 1. What's a million over a million? What's the square root of 7 over the square root of 7? 1. So we're not changing the value of this fraction. We're just changing the way that it looks. Okay? So the rule is you can multiply inside with inside and outside with outside. This 8 is on the outside. The square root of 7 is on the inside. So this just becomes 8 square root of 7 on the top. You cannot do 8 times 7. Now on the bottom, 5 times, well there's nothing out there except maybe a 1 in front of that 7. So it just becomes 5 on the outside. But we can multiply inside with inside. What's the square root of 7 times the square root of 7? Or what's 7 times 7? 49. So this becomes the square root of 49. But what do we know the square root of 49 is? 7. Okay, so we know that this just becomes 7.
So 7 times 5?
Yep. So then we have 7 times 5 on the bottom. So 8 radical 7. 7 times 5 we said was 35. Can you reduce 8 with 35? Yep. It's 35 in the prime, but it can't be reduced with 8 because you have 5 and 7 will go into 35. Okay, questions on that one? We'll do some more. You'll be fine. What do you think we should start with on H? What should we start with?
75 to 90.
The square root of 90. We're going to leave 4/3 off to the side. We're going to come back and get that later. Okay, so let's start with the square root of 90. 9 and 10. Okay, do this on your own paper. You can break a number down. So I have a group of 3's, and remember for every group we can pull one out. So this is really 3 square root of what's 2 times 5, because I have to multiply those back together? 10. Does everyone see where that came from? 2 times 5 to make 10. Okay, what do we have to do now? Any ideas?
So we multiply 3 by 4 with 3.
We got to bring down that fraction, right? Got to bring down the 4/3 now. So now I have to do 4/3 times 3, and I can put that over 1, times the square root of 10. Well, 4 times 3 is what? 12, and 12 over 3 is 4. Another way you can do that is just to cancel those out, and we get 4. So I have 4 radical 10 as my final answer. Okay, what's the first thing I need to do with letter I? Look at the one right above it, letter D, or letter B, I'm sorry. Example B. What did we do first? Okay, we split it, right? Square root of 2 over square root of 3. Okay, and now we can't reduce those anymore, but we have a radical in the denominator, and we're not allowed to have a radical in the denominator, so what do we need to do? Look what we did on example G. Multiply top and bottom by what? Not just 3. Square root of 3. This process right here is called rationalizing the denominator. Rationalizing the denominator. You need to know that. So when I say, oh, you need to rationalize the denominator, you're going to know what I'm talking about. That's what this process is called. Rationalizing the denominator. You're making the denominator a rational number. Now the rule says multiply inside with inside, right? That's what my rule says. So the square root of 2 times the square root of 3 becomes what? Good, square root of 6. And then the square root of 3 times the square root of 3 is what? Square root of 9. But what is the square root of 9? Guys, here's the hint. Anytime you multiply a radical by itself, it's just that number. Like square root of 3 times the square root of 3 is just 3. Square root of 7 times the square root of 7 is just 7. Okay? That's a shortcut to take. This is going to be finished because we got the denominator to be a rational number. We can't reduce 6 over 3. Why can't we reduce that? Because the square root of 6 is inside, right? And the square root of 6 is not just 6. It's an actual number. It's like 2.5 or something like that. See what you can do on J by yourself. Start by splitting your fraction. Okay, are you getting the square root of 60 over 12?
Yes.
Okay, now this is partway done. What do we need to do there, do you think? Reduce, right? The square root of 60 can be reduced. So we're going to reduce the square root of 60. Okay, so you're going to take your square root of 60, break it apart to whatever numbers you want. It doesn't matter what numbers you choose. We should all get the same answers. So the square root of 60 reduces to 2 radical 15. Is that what you guys are getting? 2 radical 15? Okay, so now I'm going to replace the square root of 60, just bringing it down here, to this 2 square root of 15 over 12. The square root of 60 we broke down to be 2 square root of 15. Are we finished?
You gotta multiply 12 first.
Multiply? Divide 2 over 12. I can reduce 2 over 12, right?
Yeah.
2 over 12,
1/6.
1/6. Good. So my final answer here is going to be the square root of 15 over 6. And if you want to put the 1 in front of the 15, that's fine. What questions do you have about this so far? Most of it should be review. We took it a couple extra steps than maybe what you did in algebra. Okay, does anyone have any questions about this? You'll need to look back at this when you do your homework. Okay? All right. Moving on to the next thing. This thing called the geometric mean. Sorry, I'm moving my paper. Okay, so we have a geometric mean. Do you guys remember what the word mean means?
Added all the numbers.
The average. Do you guys remember talking about that? An average, like if I took the mean of everyone's age in here, it would be everyone's the average age. Okay, well that's the arithmetic mean. A geometric mean is the middle number after you multiply them together. All right, and then you're going to take the square root. So, geometric mean says x is the geometric mean, the number that is between a and b, if a, b, and x are positive numbers. This formula right here that says a over x and x over b, you're going to need to know this. Okay? So put a box around that. Something. It says find the geometric between 9 and 7 over 3. So 9 and 7 over 3 are going to be my a value and my b value. So this is my a and this is my b. So I have my formula a over x equals x over b. I can plug in 9 over x equals x over 7/3. So I just plugged in my 9 and my 7/3 in for a and b. How do we solve this problem? Cross multiply. Okay, what is x times x?
2x.
Woo! Not 2x.
1x.
No.
Is 1x squared?
Where's my algebra 2 students? X times x is x squared. Okay? So this is new, which is fine. X times x is x squared. Can you guys see that blue okay? Or do I need to make it darker? Okay, so we have x squared. And then I have to do 9 times 7/3. How do we multiply 9 times 7/3? Good. 9 over 1 times 7 over 3. This is 3, this is 1. 3 times 7 is 21. Ooh. So we get x squared equals 21. Now this might be new to you. How do you get rid of the square?
Square root.
The opposite of squaring something is taking the square root. So we're going to take the square root of both sides. When you take the square root of x squared, the squared goes away and it's just x. The square root of 21, is that going to break down?
7, 3.
Yeah, when I break it down, it's 7 and 3. Can you go anywhere from 7 and 3? So this is your answer. Okay, so let's practice. If I want to practice the next two, okay, I know that I can plug 5 and 9 in for my A and my B value. So let's go ahead and do that. Plug 9 in for your A and B. 5 and 9 in for A and B. Sorry, I'm working on getting mine. Oh, come on. Phew. I don't know. So I get x squared equals 45. Take the square root of each side. And x equals the square root of 45. But is that finished?
No.
What can we break 45 down to? 5 and 9? Three and 3. So I have a pair of 3's. Remember, for every pair, you can write it outside. Give myself some more room here. So x equals 5 square root of 3. Is that right?
3 square root of 5.
Excellent. Good. Just checking if you're paying attention. X equals 3 square root of 5. Good. Okay, let's try letter B. It's all right that they're already square roots. You know how to handle this. Are you allowed to multiply the square root of 2 times the square root of 8? What? Can you multiply the square root of 2 times the square root of 8? What do you get? Not 16. You get, thank you, the square root of 16. Now, it would be hard to do the square root of a square root. So what is the square root of 16? 4. So we'll just make this 4. Now how do I get x by itself?
Can't you break down
Well, we still have x squared equals 4 right here, right? Now we have to square root each side. Good. X equals 2. Did that answer your question, Chelsea? Were you gonna break 16 down, or were you gonna break 4 down? Okay, if you break 16 down, you're still gonna get a group of 4's, right? Which will still give you this answer. Okay, and then you're gonna have to take the square root because we hadn't done that with x yet. All right, try letter C, please. Nine times 1/4 is just 9 over 4, right?
Yes.
We can take the square root of this. We just learned how up there. when you take the square root of a fraction, you split it up, right? When it's a big fraction like that, we separate it out to be the square root of 9 over the square root of 4. Square root of 9 over 4 is 3 over 2. Questions about that? Okay, last one.
So can we leave x equals 3/2?
Yep, x equals 3/2. So 1/2 times 2/3 gives us 2 over 6. And what is 2 over 6 reduced to? 1/3. So I get x squared equals 1/3. When I take the square root of 1/3 though, what do we have to make sure we do? Okay, separate it. So we get x squared equals the square root of 1 over the square root of 3. What is the square root of 1? 1. You can hardly see that. Okay, so I get 1 over the square root of 3. How do I deal with 1 over the square root of 3? We can't end with a radical in the denominator. Flip it, but what's that process called? We wrote it down on our paper. Rationalize the denominator. All right, so we have x equals, do not pack up yet, 1 over the square root of 3. And we know we need to multiply by the square root of 3 over the square root of 3. That's called rationalizing the denominator. So 1 times the square root of 3, well, that's just the square root of 3. What about in the denominator? What's the square root of 3 times the square root of 3? Square root of 9, which is what? The square root of 9 is just 3. All right, we're going to stop here. Anybody have any final questions? Okay, listen.